Well, it's July the 13th, and we want to welcome you to another episode. This one will be more like an episode because there is so much to talk about of Lunch and Learn. As always, we have Tony Woodard, who is the Chief Mechanical Inspector for the state of Arkansas, with us. He's the brains behind the content. He tells us what it's supposed to mean and how to administer it. And today, he's brought a good friend all the way from Fort Smith, Arkansas, who is the Chief Mechanical Inspector up in Fort Smith, Mr. Dennis Curry. So today we got Tony Woodard and Dennis Curry. Welcome, gentlemen.
Thank you.
Thank you, Tom.
You know, Dennis, I want to throw this in now, tell you how much I appreciate your area of the state. If it were not for the Fort Smith chapter of the Arkansas HVACR Association, there would be no association. It's what you guys have done over there for so many years that have given us what we needed to make our association work and work well. So a big hats off to all of you, and thank you, Dennis.
Well, that's not me. That is the gentleman in there, like Mr. Arnold, the DOG, and several contractors that put forth a lot of time, including yourself. You've been down many times.
Well, let's talk about this episode of spray foam and what in the world does it mean to you? That's where we're going, and I'm anxious to see how much fun we can have with this today. Why? We've talked about foam before. We had a whole round of it one time on our continuing education. But so why are we doing it again? Well, it's because it's growing in popularity. There is so much confusion. There's lots of humidity problems, potential humidity problems. And the last one I like, you're going to get blamed for it, whether it's your fault or not. Right now, the growing popularity. As you all know, and I'm throwing this in here, not going to take much of your time. We're talking about going from $3.1 billion a year in the nation to over $5 billion in 2035. And sometimes the numbers look even bigger. And it's growing faster with a larger portion of the market with closed sale than it does open sale, because here we see a lot more open sale. But that just kind of gives us a background on where we've come from, what we think, and where it's going. $1.6 billion a year right now is being spent on polyurethane foam here in the country. That's a lot of money. I do a lot of manual J training, and one of the things I hear from people all the time is, what's the R factor that I use? This is some quotes from a urethane foam alliance that I think is real critical. Actually, this came from NAMA. Kind of a myth or a potential truth. Spray foam delivers performance that goes beyond the R values, what the R value suggests. And yes, it does, but that's not completely the whole story. And I know that you have heard people say, hey, this R20 is going to work like an R30 attic. Have you heard anything like that, Dennis?
Oh, yeah.
Well, if a person's going to run a load, these are the manufacturer's stated values, and it varies from company to company, but we're not going to spend much time on this. But if you want to know what to put in your manual J when you're running your manual J, this is the range of R factors that you've got to use. If you get anything else, let me see the manufacturer's stated R factors.
So now, can I jump in? That's per inch, Tom?
Yes, sir, per inch.
So they're saying you're getting a 6.5 for 1 inch of closed cell foam.
That's correct.
That's what DAP says when they spray the ductwork with 1.5 inches. They're saying they're getting an R8 value on it. So, okay.
Yeah, that's, and again, depends upon who the manufacturer is. It may be as low as 6. It may be high as a little over 7. Okay, so we know it's growing in popularity. There's also a lot of confusion. And I want to get past a lot of this really quickly, because the real heart of what our guys need to get into is not how to put it in, but to know that when they start seeing an attic that's been encapsulated, it's important to them. And for those of you that are watching this on YouTube, you can stop this thing and go through it, go to the cell references, and you can see the various ways to install it that are okay and what code requires and how to do it. Here's where we come into something that's pretty important. Tony, you want to look at any of this and speak to it?
Yeah, I will speak to it, and I will throw in one thing that you had. My son is the engineer for Atlas Roofing, so he's the engineer over that, and he's been involved. He's actually in Ohio right now as we're talking.
Hmm.
They have a disclaimer on there. Now they sell the 30, 40, 50-year shingles for up north, Michigan, Minnesota, so forth.
Right.
They have a clear disclaimer. You can, I mean, they have shingles they make, but if you spray the deck, you have to use a certain shingle that
Is that
they've
right?
gone, yes, sir, because of that heat that's tracking from noon right now in the daytime we are right now with a 95-degree day in this, it is heating that attic until
Yeah.
midnight. And then you
Yeah.
have a transfer of temperature. It's molecularly moving and it creates issues. And they had to learn to develop a shingle just for spray foam decks. They sure did. So it's kind of interesting. Now I'll get to this. I hope
Okay.
builders that watch this understand. You go throw that just simple 3-tab Tapco shingle on there, you got a problem. You
Hmm.
got to have some serious deal. And that air permeability of the installed on the deck and the floor, and as we talk about that ceiling, brings us to what did we do to the attic? Do we have equipment up there? Are we going up there just for storage to, like Dennis said earlier, we putting our Christmas up there and we're going up there getting our Christmas. That's okay. You can use the open sale. You can knock yourself out and do whatever. Once you put an appliance up there, you've changed the whole dynamic of that, and you have to at least meet the ignition barrier, which is a 15-minute, whether you use the mix policy. But I've got a simple solution with inspection for my guys, and I met with some of the foam. Open cell pure foam is so dull, and you can poke it with your finger. When
Mm-hmm.
they do mix an ignition barrier, it gets a semi-gloss or some kind of glossy shine, and it starts getting a little tougher. The closed cell full thermal barrier, it's really hard. It's shiny and it's hard. So we can just physically look at it and go, well, you don't have nothing. If you do, give us our documentation. And we see that every week because it is getting popular.
Well, there's a lot of varieties and ways that it's okay, according to code, to put it up there. You can put closed cell foam on top of the deck. I've never seen that. Don't know if I ever will. You can put closed cell foam on the bottom of the deck, and then it would be like an inch or two, and then fill the rest of it out with open cell. Or if you don't want to do that, you can do it all with closed cell. But here's this 5.2.10. If you're going to use open cell exclusively, you got to have something up there to help get rid of the humidity. I think that's true also if you're using closed cell, but certainly with open cell, you've got to do that. In this particular case, it says you got to use 50 CFM per thousand square feet.
Yep.
That's
And don't that remind you? Look at that number. That's the exact same number that's required when you try to do combustion dilution air on a fuel fired or combustion chamber to prevent
uh,
carbon monoxide. So these numbers are matching, but this is not what they're saying here. So, but
Dennis, what were you going to say?
It's actually 50 CFM per cubic feet for combustion air, not square foot. This is square foot.
no,
So,
you're all right. That's right. You're talking 50. Correct. He's correct. That's right.
all right. Yeah, here this is square feet. You were the other thing was cubic feet, right?
What Mr. Woodard's talking about is if you want to use inside your house for combustion air, you
Oh,
have to have 50 cubic feet per 1,000
BTUs,
BTUs.
BTUs, actual BTUs, not square footage.
yeah. What I can't imagine in a residential application anybody using the unconfined space rules to be able to get their combustion ventilation air
I'm,
anymore. Does that happen?
I just had two more. Something we were discussing earlier, didn't quite get to it. They'll put an 80% furnace in the attic. Heat and air guy didn't know they were going to spray foam. That
Okay.
was the decision the builder and the homeowner came to later and didn't inform him. And when he goes out to final his equipment goes up there, all of a sudden he's got a foam house. And he's called me saying, what do I do now? The options the state has given me, unless they've changed, is you can build a room around it with a door and bring it in. They've also let you control your combustion air by BTU size and bring it to within 18 inches of the burn chamber. But now you've lost some of your energy efficiency because you've broke your envelope. Even though you're controlling it, it has to free move, so you can't damper it. You have to size it right and let it free flow back and forth, which is now you've went into your attic area that's part of your envelope and opened the window. And
Okay, we are accustomed to, if you've got an 80% furnace in a hall closet, we know you've got to bring in combustion and ventilation air, right? So in essence, what you're saying, if you find out that you've got an 80% furnace in an encapsulated area, you got to do the same thing. That's run a pipe all the way through the roof, two of them, right?
High and low, correct.
Yeah, I
Or
understand.
or you
now
can
you
build that
can
mechanical. You could build that mechanical room, but again, you're sealing this off. You're going to have an exterior door with a threshold. You're going to build a floor. You're going to sheetrock that all the way down, and then you're going to control that room where that fuel-fired appliance is. And
Yeah.
you've got to have your clearances for everything. So the door would have to open. Now you got your 3 foot back there. You're going to have clearances left and right. It's that's a lot of adder on. And what gets me about when they say, I didn't know they were going to foam it, what did they just do to their manual J load? So wait a minute.
Ooh.
Hold a second here.
Well, now I'm getting off track. I need to ask you a question, Tony and Dennis. My recollection on when a person needed to build like a little mechanical room around the equipment was that if it was getting too close to the foam because of an ignition problem.
All right, that was pre 2012. The IFC, International Fire Code, IBC, and the IRC. When we adopted the 2021, IC got ahead of this and said, okay, we're going to solve that problem, because if you're going to have a torch up there, then you're having an appliance up there. Now we're making you cover that area with a minimum of an ignition barrier to stop that. And it really was more about, if we had an 800-degree torch, we could be within 6 feet. That open cell foam was actually off-gassing and creating a hazard before, not the ignition part of it, it was off-gassing. Now we're going to put the ignition barrier on there and shut that down. So they got ahead of that. Now we're in 806 about the attic issue, but in IRC 316, it gets in depth on what you got to do with your treatment of your foam for this such appliance. Like you said, if you're just going up there to store something, you're okay. But you can put a simple humidistat fan up there. Now you got a model and serial number. Now you have an appliance. Now you're going to have to put the ignition barrier up there. The whole attic, unless you try to do that one little room. Again, that room would have to be built all the way to the deck.
If you can tell, my jaw just dropped. One, not understanding exactly, and number two, wondering what in the world are we doing to ourselves in our industry. Somewhere along the line, we've got to communicate better with our builders and with our insulators, with all of the trades, to figure out what are we doing. And I won't get into this because this is something that people can look at when they watch this on their YouTube. They can kind of look at it a little closer. We really don't have time for all of that. There's lots of confusion. Now then, but let's talk about the potential humidity problems that one has in an attic if it's an encapsulated attic. Here's a really good thing that the commentary from the 21 IRC has. It says that in a typical day, your house, just a typical house, is going to produce almost 3 gallons of water. And it's going to try, most of it's going to try to go up through the ceiling and then try to get out through the attic. But there's even more if you have a humidifier or a washer and a dryer. Now, if you have sealed that attic, how are you going to get rid of that humidity? That's my question.
Go ahead, Dennis.
So there's a lot of ways. The best way would be a form of ERV that's doing just the changes with the attic space.
Okay.
Not mixing with the occupiable zone below. That'll help control that humidity. That's probably the best. The second best would be to put a dehumidifier in that attic. They build them specifically for that. It has a drain just like your air conditioning unit, a condensate drain. Of course, we're going to drain the moisture we pull out of the air and take it away from there and drop it outside somewhere or to an approved location. And if you keep the humidity down, the comfort level gets better, even though that's not occupied space. It reduces the load on our ceiling, which makes our equipment more energy efficient. And we don't have a mold mildew problem. So both of those can help prevent, if everything's installed right, mold and mildew problems long term in your home. The third way brings a lot more codes to bear, and that would be I'm going to cut a little 3-inch hole in a supply on one side and a 3-inch hole on the other side. By doing that, in essence, we put it in the breathing zone. Now we're not talking ignition barrier, we're talking thermal barrier or encapsulation. That's adds a lot more expense, but it will control the humidity and temperature in that unoccupied attic space with the equipment. But if you do that, one thing to bear in mind that hits on something from 2 minutes ago, you can't put an 80 plus furnace up there because you can't put a supply and return in your mechanical room while going into a breathing zone in a residential. And you've turned your attic into a big mechanical room if you put an 80% open combustion. So
Okay, let me go back a few years. I remember several years ago where there was all this first discussion out there. And one of the things we said is that if you were going to do what you just said, which I like the concept, but if you were going to do that, if there was anything like a fire in that attic, you wouldn't see it, but it would pull the smoke into the return air. Therefore, you'd be distributing the smoke from the attic all through the house. At which point, my suggestion, only a suggestion, was that if you're going to do that, you ought to put a smoke detector in your return air up there. Is that, you remember those conversations we used to have?
That is being discussed. I don't believe they got it in the draft of the 2027. I was on a Zoom call. That is being discussed to add residential, and it's not just foam. It's due to some of the cladding we have. That is being discussed heavily. And with the R2, the A2Ls, we are talking about a monitoring device on every single family dwelling return. But they're trying to decide, will it just be smoke? Will it be a refrigerant gas? Will it be a methane? They're discussing that as we talk, and that's coming. That's coming. So you'll be seeing that on the return side of every single family, probably by 2029.
You know, we've only been talking about this for about 15 years.
Yeah.
I remember those old conversations. Hey, here's something that I wanted us to think about, and that is if you've got open cell foam. Open cell foam is a pretty doggone good air barrier, but it doesn't stop vapor from moving. And one of these studies showed that if you got open cell foam and that's all you've got on your deck, when you get humidity in the attic, what Tony, you were explaining a while ago. You take over.
This right here, we have a molecular movement from noon. That heat that comes down and penetrates that, it doesn't stop. It just because it's noon and now it's 8 o'clock at night and the sun's gone down. There is a molecular going in the open cell foam. It's expanding, it's doing all this thing. And up on the deck side is where it starts doing this. And it'll start rotting there and rot throughout. And you pull your shingles up. And that's when you see it. So, yeah, there's ways to get moisture in there. You get a crack. If you get a hole in it or something, it can create. And just like you were talking about when they encapsulate these houses and run their dryer vents through the roof, if they don't seal that dryer vent with mastic, which we don't have a code that makes that, it just says seal, 603, they can seal it with regular. If that thing comes loose, think about all that hot, moist air you're just dumping in the attic off that dryer every time you run it. Now, that's just, and we have the elbows and gores and elbows, all that stuff.
Here's an example of an OSB clip on the decking there that had open cell foam below it to show how that vapor does go through there and wind up rusting that piece of metal that's there. But everything has got to have a good installation practice and a good application. If you use them the way they're supposed to be used, you don't have stuff like this. That's don't have it.
That's correct. And again, there are some good applicators in Arkansas that really take their time to do it, and they do a great job. The ones I've seen have been close sale on the deck. I would really have liked to seen the backside of that where the shingle comes up. I'd like to seen the other side of that decking.
Yeah.
I'd like to seen that.
Also, it mentions that this would be primarily be retrofit. If they're going to put foam on the deck, they've already got some kind of insulation down on the ceiling, they need to get rid of that because that will create a moisture problem. And this comes from the Spray Polyurethane Foam Alliance. This is a big industry organization for the foam folks, and they are good quality people. And they're saying you're going to use our product, make sure you don't create a negative for the product. A lot of our folks are thinking, why in the world are we spending time on this? Not my world. And yet, your ductwork's in the attic, and code says you got to do what you got to do to prevent the formation of condensation on the exterior of any duct. If you don't know what the condition of the area is that you're putting your duct, how can you plan to make sure your duct's not going to have condensation on it?
Got to be insulated. Got to be externally or internally insulated, plain and simple. And it's got, according to our deal, an R6 minimum throughout.
Well, we've already talked about this here. We jumped ahead on the thermal barrier versus the ignition barrier because it affects how and where you put the equipment, and all of this goes into how to get a thermal barrier, how to get an ignition barrier. But again, y'all can look at that when you're looking at the YouTube version of this. This is a neat little picture here that shows that you cannot put boxes in your attic with foam insulation up there unless you have a thermal barrier up there. And that's IBC 2603.4. Y'all can read that. You can choose to live with it or not live with it. I don't know anybody that's living by it, but that's what it says. Did I interpret that right, Tony?
You did. And my interpretation, anybody that gets in their 60s, don't take nothing up in the attic anyway. You dang sure don't be walking around with that.
Is that ever true?
That's so true.
So that covers the humidity problems. And then the last one is you're going to get blamed. Yeah. I don't know why a heat and air guy gets blamed for absolutely everything that goes wrong. But if it's got to do with ventilation and it's got to do with a moisture problem other than a piece of plumbing breaking and spraying water everywhere, the HVAC guy gets blamed for it. So we kind of got to know what's going on in a house. We got so many areas of all the trades that we got to know something about, and really quite a bit about. It gives us an opportunity to show that we are the professional industry doing our best to take care of the comfort needs and the health and safety needs of our customers. Did I get on my stump?
No, you didn't. I do have a question since you did a lot of research. I'm just curious as to the growth. Are there a lot of like North Carolina, and are they getting a serious payback or with their utility providers, like how when you do at the end of the year, if you buy, they're giving you a $3,000 tax credit for that? I'm just curious if something like that is what's driving such the industry to go towards that and to something like that. Do you know?
I just know there was a federal tax credit, and most of that has been done away with, but that was a pretty nice tax credit that they were getting. My question is that you're going to spend more for the good foam on your deck, and then you're going to be told, well, you got to put in a $3,000 HRV, ERV, or a dehumidifier, and I'm trying to figure out where do you start getting the payback? I don't know. And I think it's great. I mean, it's good stuff. I've seen houses with it, and you can walk in there and it is almost like walking into your house, because it's going to be, Dennis, my experience is that what I read is that it says that your attic's going to be within about 5 or 6 degrees of what the house is. Is that what you're running into?
As a general rule, it does. And your payback is over the life. So if everybody, all the trades do their job right with your spray foam and it's installed properly, proper shingles, proper underlayment, everything sealed up, your payback can be for 20 years in our area of 4 months of air conditioning. And if you can tag $50 off that bill and we're talking a lot of people's bill runs $300-400.
Yeah.
If I tag 50, I save 200 a year for 20 years.
Yeah.
If everything's done right and you don't have a storm or freak, it's not uncommon to get that long of use out of it. You're saving some serious money in offsetting. And there's more savings in there with comfort. Your temperature, you will set a little higher because you're dehumidifying properly. So you're more comfortable at 76, which means you're not using as much electricity, which means you're helping if you want to go ozone or energy grid, climate, anything that cuts some of that out is, the pennies add up, not just in your pocket, but, for the globe.
Tony, we've talked about spray foam on the duct before, so we won't go into that today because I've kind of run long today already. I want to thank you and I want to thank Dennis for being a part of the program today. I've learned a lot. You can tell the whole subject has a tendency to confuse me, but I also know that what we really ought to move toward is having a home builder have I don't know what they call it in the commercial world, but like an organizational meeting where all the trades come together and say, we're doing A, and somebody else says, we're doing B. Do you see any conflict between those? How can we work together to make it happen? If we would get our home builders to just say, you're not getting my deal if you don't come over here and tell me what you're doing with heat and air as it relates to insulation, as it relates to plumbing, as it relates to electrical, because we're not going to have any problem. If they do that, that'd be a wonderful thing for the homeowner because everything would work right.
I agree. I agree with you 100%.
Anyway, this has been Lunch and Learn, the episode where we get to talk about foam in a house and how it relates to the HVACR industry. I want to give our compliments to the Department of Labor and Licensing for furnishing inspectors to come talk to us about issues that are so important to our industry and ultimately to the homeowner that's out there. If you've got any questions or compliments or any code related issue, call 501-682-9201. Look, they're busy. They're not going to be able to take that call first time, every time, but they will get back to you and they will answer your question. That some of the nicest people you'll ever run into are the staff up there at ADLL. We'll be back Monday, August the 10th with another session. Tony, I hope you'll be available. We look forward to it.
If God will let me be here, I'm planning on it.
we're going to talk to him about that. Thanks again. We appreciate y'all for tuning in and
thank you, Tom.
Bye now.